So, oops, I forgot to record. So now I'm recording. So I'll tell you what, let me stop sharing that stuff with you guys. And I'm glad you all are here. So let's see. Glad you all are here. Does anyone have any questions, about homework or anything before we get started? So those of y'all are here, anybody got any questions about anything from chapter 12, y'all? Anybody have any questions about any of that stuff that y'all might want to ask me about before I do anything new? Don't be shy, don't be shy. This is why I'm here. Nothing on chapter 12, so Diana, you're okay. Okay, awesome, good, good. Okay, well, guys, y'all seem to be doing really well. Really happy for you guys. Y'all been doing so well this summer, and that's why I went ahead and I opened up some of those assignments or the stuff for week 2 last week, because I had gotten multiple messages from people saying, hey, you know what? I'm already done with chapter 12. Can I get started on chapter 13? And so that's why I went ahead and opened up that stuff, right? So guys, just a friendly reminder that everything from chapter 12, those first, I think y'all had 4 homeworks and a quiz. That's due by tomorrow night. And then the stuff from chapter 13 is not due until the following Tuesday. And then guys, also in the week 2 folder, I did share with you guys the information about the midterm exam. So right now we're going to be using Zoom. If anything changes, I'll let you guys know. But right now I think we're going to use Zoom. Sometimes Zoom can be kind of, I don't have like a professional account, so a lot of times it only gives us a 40-minute time span, and it doesn't mean that you only get 40 minutes. It's just that after 40 minutes, it'll log everybody out. We all got to click on the link again, and then we all come right back. So I'm trying to see if there's something else I can use. I'm using Teams for my other classes, but I have 3 classes this summer. So when I'm testing you guys, I'm actually testing another class as well. So I'm going to have 2 computers set up, but I'm going to see if we can maybe find something so that the Zoom thing doesn't kick us out, all right? Anywho, let me see. So what I'd like for us to do then, y'all, since y'all are good with homework, is I was going to go over a little bit of chapter 13 with you guys this afternoon or this evening, and just to make sure that you guys feel okay about factoring and factoring by grouping, okay? So 13.1 is the greatest common factor in factoring by grouping. Give me 1 second. I'm going to check something, guys, before we get started. So let me do something real quick. Here we go. This is us. And let's see. Here we go. Okay. All right, yeah, let's go ahead and go over this section here. So guys, the first thing we have is something called the GCF. So what the GCF stands for is something called the greatest common factor, okay? And so what we're trying to do here when we're factoring out the greatest common factor, we're basically going backwards from multiplying polynomials. So what I'm going to do here is I'm going to look at this expression, and it has 2 terms. It has a 5x and it has a 35. So what I'm going to do is I'm going to ask myself, those 2 terms, 5x and 35, do they have any common factors? Do they have any numbers that are common to both of them? And we might say, yeah, you know what? 5 is common to both 5x and the 35, right? So what I'm going to do here is I'm going to put this in parentheses. And the idea is I need to figure out what would I need to put in the middle in those 2 spots here, so that when I multiplied my 5, we would end up with 5x plus 35, right? So we might say, well, look, here we have a 5, but we took the 5 out, but we still have an x. So I'm going to put an x right there. And then 5 goes into 35 7 times. And so if I were to multiply this out, 5 times x would give me 5x, and 5 times 7 would give me 35. So this right here, y'all, this is my answer. We're basically going backwards. We know what the answer is. We're trying to figure out what was the problem, okay? So let's see if we can do the same thing here. So I want you to notice this one. We got a 24x and a 6. So this is called, we're factoring out what we call the greatest common factor, right? So when I look at 24 and 6, I might say, well, hey, you know what? I can divide them both by 2. Or I might say, look, you know what? I can divide them both by 3. Excuse me. But because we are dealing with the greatest common factor, we can actually factor out a bigger number. We can factor out a 6. So I might say, well, look, 6 goes into 24 4 times, and there's an x right next to it. So I'm going to keep that x on the outside. How about that, guys? My phone just went off. And then 6 goes into 6 1 time, and there's a minus in the middle, so I'm going to keep that minus right there in the middle. And now I'm done, right? And that's all that I got to do right there. So anyway, let me ask you all a question. How does these two problems here, are they making any sense as I'm going through them? Am I doing all right? I just want to make sure that we all feel okay. Is this making any sense? Yeah, so far so good? Okay, awesome, good. Okay, let's take a look at the next one. So look, I have x to the 4th minus 5x to the 3rd, okay? And I'm going to do the same type of thing here, y'all. I'm trying to figure out, excuse me, what can I take out of both those expressions, right? Both those pieces. And so I would say, well, look, in terms of numbers, I don't have any numbers in common, but I do have x's in common, okay? So I'm going to write this out real slow. Look, x to the 4th means that there's 4 of them, and 5x to the 3rd means that there's 3 of them. And I want to take the most that I can take from both of them. So the most I can take from here, because the most I can take from here is 3, then the most I'm going to take from here is also going to be 3. So look, I'm going to end up with an x to the 3rd. And what I'm doing, y'all, is I'm taking out that x to the 3rd from both of them. Well, now, look, how many x's am I left with here? Just 1. And what else am I left with here? Just the 5. So again, the idea is if I were to multiply this out, this is what we'd end up with, right? But this piece right here, y'all, that's my final answer. So we're taking out, again, what we call the greatest common factor, the most that we can take out. And the most that we can take out, y'all, when we have like expressions like this with x's, the most we can take out is the one that has the smallest amount, okay? So let's try to do the same thing for this problem right here. So the first thing I notice, I can take out a 3 because 3 goes into both those numbers, right? 3 goes into 3, and it also goes into 27. And then in terms of the x's, I can always take out the one that has the least, the smallest one, which is an x squared, okay? So now look, we've already taken out the 3, so I'm not going to have any 3's here. We used to have 5 x's, and we took away 2 of them, which tells me we should still be left with an x to the 3rd, because 5 minus 2 is going to give me 3. And then 3 goes into 27 9 times. We had 2 x's, but we took them out. And so that right there is all we're left with. Okay. All right. I'm going to do the same thing over here. So when I look at this problem, the first thing I notice is they both have the letter y. So I can take the letter y out of both of them. If I take the letter y out of here, I'm left with an x. If I take the letter y out of here, I'm left with a 3. And I heard something in the chat, so let me come back over here. And, okay, why do we take away the smallest? Good question. So let me show you what I mean by taking out the smallest. So remember when we did, let's see, this problem right here, And remember why I wrote that x to the fourth? I said, look, that really means that there's 1, 2, 3, 4 of them, right? And then the 5x to the third means there's 1, 2, 3 of them. So I have to take the most x's that I can take from the entire thing, right? But look, from here, I can only take away 3 of them because that's how many x's I have on that 5x to the third. There's only 3 of them there. So if this is going to have 3 of them, then I can only take 3 of them from here as well. I have to take the same amount, okay? So when we took out those 3 x's, remember, that was really the same thing as x to the third. So when we take those 3 x's out, look at how many x's we're left with. We're just left with 1. And right here, we're just left with that plus 5. So the same kind of thing goes here, right? So they both have to give up the same number of x's, and they're going to give the most that they can give. But the most x's that this guy can give is 3 of them, because that's all that it has, right? Sometimes my pen freezes here, guys. Okay, that's the most x's that guy can give is 3 of them, because that's all he has. So if this one can only give 3, then that one's only going to give 3, right? Or the same thing over here. The most x's this one can give up is 2. So then this one's also going to give up 2, okay? So I hope that makes a little bit of sense and how we did that part there, okay? All right, so guys, let's take a look at the next one here. First thing I want you to notice, let me see, I heard something in the chat. Okay, good, perfect, I'm glad it's working. So first thing I want you to notice here, this one has a y plus 6, and so does this one. So I'm going to write this out right here, y plus 6. They're both giving up the y plus 6. So what do I still have left over here? I still have an x. And what do I still have left over here? I still have a plus 3. Okay. All right. So I'm going to do the same thing here with this next one, guys. I'm going to say, okay, what can I take from all of them? Well, the number that goes into all of them is a 3. Okay. So we take the 3 away from here, we're left with an x. Now, when I'm going into here, what I'm really doing, y'all, is I'm dividing, right? So 3 goes into 12 4 times with a y. And then, because we said we're dividing, 3 goes into 3 1 time, right? A lot of times people ask me, do I have to write the 1? Yeah, we really do. Because remember what we're doing here. We're saying this here is the answer. And if we said, you know what, I wanted to make sure that this answer is really going to work out, we would say, well, look, 3 times x is 3x. 3 times minus 4y is minus 12y. And 3 times 1 is 3. And this is what I would be left with as I'm doing my check. And so I really have to put that 1 there, okay? Alrighty. So let's take a look at the next one here. It's 6x to the third minus 12x squared plus 9x, okay? And I'm going to do the same thing here. So I'm going to say, look, what number goes into 6, 12, and 9? Let me ask you all a question. Do you know what number is common to 6, 12, and 9? What is the common factor for 6, 12, and 9? Anyone know? There you go. Very good. 3. Perfect. You got it. Excellent. So look, we're going to take out, from here, y'all, we're going to take out a 3. Now, on this x here, even though I don't see it, the power on that x is a 1. So remember, we have to take the smallest of the x's. So we're only going to take out that 1x, okay? And now we're going to go in pieces. So 6 goes into 3 twice, right? You don't have to write this here, guys, but I'm going to write it because I think it's helpful to do it. So I'm going to put a 1 right there. Now, remember how many x's we used to have? We used to have 3. We took away 1. So we're left with 2. Okay. Minus 3 goes into 12 4 times. We used to have 2 x's, but we took away 1. So we're still left with 1. Okay. Plus 3 goes into 9 3 times. We had 1x, and we took it out. So we don't have any more x's. And so this right here is going to be my answer, okay? So, did that one make sense, guys? How we went through that problem there? Yeah, we're okay? All right, just checking with you guys. Okay, so let's take a look at the next couple of problems here. So this next problem here, what we're doing is we're trying to see, okay, what do they both have in common? Well, look, they both have an x squared plus 2. So that's what I'm going to take out. I'm going to take the x squared plus 2. And if I take away this x squared plus 2, I'm still left with this y that I have here. And if I take away this one, I'm still left with that plus 3 right there. Okay. And you know what? I don't even know if I'm recording. Am I recording? Yeah, we're recording. Okay, just checking. I wasn't sure we were. All right, so guys, I'm going to do the same thing here for this next one. So I want you to notice this part here is in parentheses, as is this one. And right here, I see the letter R. If I don't see anything in front, y'all, it's supposed to be the number 1. Okay. And so we can say, look, they both have a z to the third minus 6. So I'm going to take away that z to the third minus 6. And then what am I left with? An R. And what am I left with here? A plus 1. So guys, in the video that I have on YouTube, I made a mistake and I put a minus 1, and it really should be a plus 1. Okay, that was just my mistake. So I just want to let you guys know, okay? All right. Now, the next piece here, guys, and these parts are really important because this is how I kind of do the problems out of 13.2 and the next one, 13.4, is we do something called factoring by grouping. So factoring by grouping says, and this happens, guys, we're always going to have here, we're always going to have 4 terms, okay? In factoring by grouping, we're always going to have 4 terms. And so what we're going to do is we're going to group them. So I'm going to pretend like this piece isn't even here, okay? We'll deal with that part in a little bit. We're going to factor out the greatest common factor just from those first 2. So I'm going to say, look, this is an x to the third, and this is an x squared. The most number of x's I can take from both of them is 2. So if I take out an x squared from here, I'm still left with an x, because there was 3 of them. We took away 2, we're still left with 1. And out of here, if I take out the x squared, I'm just left with a 2 now. Okay. All right. Well, I can't really just pretend that part isn't there because it really is there, right? So now the second thing I'm going to do is I'm going to look at these 2. And I'm going to say, what can I take from a plus 5x and a plus 10? Well, the number that they both have in common is the number 5. So if I take out the 5 from here, I'm left with an x. And 5 goes into 10 2 times. Okay? And so now, look, when this piece here and this piece here match up, then we know that we're on the right track. So what I'm going to do here is I'm going to write this as x plus 2. These 2 here collapse into this one factor. And then this guy, along with that one, is going to be my second factor, okay? And so, guys, we always want this piece here and this piece here to match up, okay? And for the most part, like 9 out of 10 times, they're going to match up. Does it ever happen to where they don't? Every now and then, but for the most part, it works out, okay? So look, let's try the next one. We're going to go ahead and do the same method. We're going to go through factoring by grouping, okay? So the first thing I'm going to do, I'm going to put a box around these 2. And this is all I'm going to look at. I'm just going to look at what I have in the box, okay? And I'm going to say, what number can I factor out of both of them? Well, we can take out the number 5. And if we take out the number 5, I'm left with an x plus 3. And then I'm going to put a circle around these 2 guys. I'm going to say, what do they both have in common? Well, they both have the letter y in common. So if I take out the y from here, I'm left with the x. And if I take out the y from here, I'm left with the number 3. Okay? And then if this piece here and this piece here match up right, then those two are going to collapse into one factor. Oops. Into one factor. And this is going to be my second factor. So guys, before I go on, how do you guys feel about grouping? Is it working so far? Are we doing okay? Yeah, we're doing okay so far? Okay, just checking with you guys. All right, just want to make sure, good. We're good. Sergio, tell me, which one did you have a question on? For answer to 3, you believe. Okay, let's see. Let's go back up. This one here? Let me see. Okay, so let's see. Let's go over this problem, and then we'll or let me ask you a question. What specifically is the question that you have? If you want me to just do the problem again, I can definitely do the problem again too. Okay, after we find the GCF, that's where we stop. Because for these problems here, all you're doing, okay, because this is all we're doing. The directions for these problems here are just asking us to find the greatest common factor. Okay, when we get to like 13.2 and 13.4, the problems go a little further. But for these problems here, let me see if I can scroll up. It's just asking us right here to factor out the greatest common factor. So that's all they're asking us to do. Good question. Good question. Okay, so guys, I'm glad we got that cleared up. So guys, let's come back over here. Let's go to the next one. So the first thing I want you to notice about this problem is the order. What I mean by the order is, if you look here, this is the x to the third, but then the x squared is over here, and then the x is over here, and the one with the number is just over here. So what we're going to do, y'all, we're going to switch these two around so that the order is kind of like the right order. Like what I mean by the right order, it goes in descending order, okay, from the highest to the lowest, okay. So what we're going to do, we're going to just switch these two around. So the first thing I'm going to do, I'm going to write down 16x to the third minus 28x squared plus 12x minus 21. And guys, remember, the grouping method says we're going to look at the first two. So here are my first two. So let me ask you all a question. What's the biggest number do you think we can divide both into 16 and into 28? Anybody know? Let's see, I heard something in the chat. Okay, why are we flipping it? Why is it flipped to begin with? That's just the way it was written. And so sometimes in your homework, it may be written that way, Diana. So what I'm doing is I'm writing it in the order where the powers go from the highest to the biggest. Okay? So that was just the problem was written, so we're going to go ahead and do it that way. Excellent question. So guys, let me ask you all a question. What is the biggest number do you think that goes both into 16? Okay, so I know 8 goes into 16, but 8 doesn't go into 28, right? So we got to go a little smaller than 8. 4, perfect, very good. So guys, you guys are doing great. So we're going to factor out a 4. In terms of the numbers, we're going to go with a 4. And then remember, we said we're going to go with the smallest of the two powers. So we're going to go with a 4x squared. Okay. Now look, 4 goes into 16 4 times. We had an x to the third, but we took away 2, so we're only left with one of them. And then there's a minus right here, so I'm putting a minus right here. 4 goes in 28 7 times. We had an x squared, but we already took it out. Okay. Now, let me ask you guys another question. Let's look at these two right here. What number do you all think goes both into 12x and 21? There you go, perfect, 3. Excellent, good. So 3 is going to go into both of them. So 3 goes into 12 4 times, and 3 goes into 21 7 times. And guys, notice something here. This piece here and this piece here, they're matching up, right? So we know they're matching up. That tells us, hey, you know what? We're doing this the right way. So then my other factor is going to be 4x squared plus 3. Okay. All right. So far you guys are doing great. Let's keep going along here. So I want you to look at this next piece right here, guys. It's an 8x squared and a 7xy. So what would you say both of these pieces have? Is there anything in common to both of them? Whether it be a number or a letter, do they both either have the same number or do they both have they both got an x? Perfect. Very good. Okay, so we're going to take an x out. So remember, if we had 2 of them, but we took away 1, well, we're still left with 1 of the x's, right? And if we took the x away from here, then we're just left with a 7 and a y. Okay? Now, let me ask you another question. Look at these 2 pieces over here. Does it look like they have anything in common? Do they both have an x? Do they both have a y? Is there a number that goes into both of them? Very good. So guys, if there's nothing that we can see that goes into both of them, so that goes right. We can always divide them both by the number 1. And so we want to go ahead and do that. So we're going to put a 1. And remember, the 1 isn't going to change anything at all. It's not going to change my numbers on the inside. But the reason why we want to do that is because now we can say, look, these 2 pieces in parentheses are matching up real nice and pretty. So then we can write this as our second factor, right? Good, good, good. Okay. All right, so guys, let's take a look at this next one here. First question I want to ask you, the 2x to the third plus x squared plus 8x plus 4. Does it look like those are in the right order? Do they go from the highest power down to the lowest? What do y'all think? Yeah, they are from the highest to the lowest. Okay, good. So we don't have to change anything. We don't have to flip anything because the order is perfect as it is, okay? All right, so first thing I'm gonna do here, y'all, I'm gonna put these 2 guys in a box. And do they both have anything in common? Or let me ask you a question, and we know they have stuff in common. What's the most number of x's I can take from both of them? Do you think I can take 2 x's or do you think I can take 3 of them? Meaning, would I take out an x squared or would I take out an x to the third? 2 of them, excellent. Pretty good, excellent, guys. You guys are doing great. All right, so we're gonna take out an x squared. So if I look at this piece, I still have the number 2 in front. We had 3 x's, but we took away 2 of them, so we're just left with 1 of them. And even though I don't see it right here, y'all, the number in front of this x squared really is a 1. So since we took out the x squared, we still have that plus 1. Okay. Now, let's go ahead and circle these 2 guys. What is the biggest number that goes both into 8 and into 4? What do you think? The biggest number that goes into both of them? 4. Excellent. Very good. So now, when we take out the number 4, 4 goes into 8, we said twice, and 4 goes into 4 once. And then again, if you notice, y'all, we're doing this the right way. So we end up with a 2x plus 1 and an x squared plus 4. Okay. Good, very good. All right, excuse me, I'm sorry. So now let's go ahead and take a look at this next one here. We're going to do it the same exact way that we've been doing so far. And guys, really, these problems, they're not that tough. They just take a little bit of practice. And the more that you practice, the better that you get at it. It's like anything else, right? All right, so here we have 4x squared minus 8xy. So I know we can take a 4 out of both of them. And they both have x's, so we're going to take out an x. And so if we have a 4x squared, but we took a 4x out, we're still left with an x. Now there's a minus, so I don't want to forget my minus. 4 goes into 8 twice, and I still have the letter y. Okay. Now, I'm going to circle these two. Now notice the way the circle part looks, guys. So I'm going to kind of just zoom in for right now, because I really want you to see this piece. The first thing I see in front of my 3 is that it's negative, okay? So whatever it is I'm going to factor out, it's going to be a negative number. So I might say, well, look, between 3 and 6, we can take out a 3, but because there's a negative right there, we're going to take a negative 3 out. What that's going to do, y'all, it's going to change my signs. So this piece here, instead of being, right now it's negative, it's going to be positive. Because notice, negative 3 times x gives me a negative 3x, right? And I know 3 goes into 6 twice, and there's still going to be a y, but this needs to be a negative also, because a negative 3 times a negative 2 would leave me with that positive 6, right? So now we can write over here minus 3x minus 2y, and I want you to notice that this piece here and this piece here match up exactly. So guys, that's the one thing, they have to match up exactly. They can't be like, oh, it kind of looks like it and it kind of doesn't. It has to be exactly the same thing, okay? So now we're going to have an x and a minus 2y and a 4x and a minus 3, and then we're done. And so that looks like that is the end of 13.1. So let me ask you, yes, sir, tell me, Sergio. What's your question? Okay, the order. Very good question. So guys, I'm glad Sergio asked that question. Is it always going to be this way and the other way? Like, is it always going to be this piece here coming first and then this guy here coming second? Not at all. You can always write your answer like this. The order in which you do them is not important. I want you all to remember what it is we're really doing here, right? The operation really here, guys, really is multiplying, right? So when you multiply numbers, when you say 2 times 3 is 6, you can also say 3 times 2 is 6. You can switch those numbers, and it's not going to make any difference. Every time I do my problems, I always just say whatever my common factor is, I always just put it first, but you can put them in any order, right? The one thing that has to stay the same is if this is an x minus 2y, then you got to write exactly that. And if this is a 4x and this is a minus 3, then you got to write exactly that. You can't kind of like mix and match. But whichever one you put first, whichever one you put second, really doesn't make any difference at all. Okay, you can do them in either way that you want. Excellent question. Do you all have any other questions you'd like to ask? Okay, so Diana, what I'm going to do, I'm going to send the link to this video on Pronto. Okay, I'm going to send this out on Pronto, so I'm recording it right now, and then I'm going to download it, and then I'm going to send you guys a link on Pronto, and I'm going to upload it to YouTube, and then I'll send it to you guys through Pronto. But if you go to my YouTube page, I know what I provide you guys is with a playlist, but look, if you click my name, you'll see something like MATL 0014 class session, and I'll have today's date, like June 14th. So you'll be able to access it there. And then remember, there's the playlist in YouTube also, right, for our class. It's in the week 1 folder and the week 2 folder, right? I always can give you guys the playlist. But this specific one, you'll definitely, you guys will definitely have it today. Guys, any other questions y'all want to ask me about anything? So, guys, instead of me going on to 13.2, I don't want to do that just yet because I want you all to have an opportunity to go through the homework for 13.1 and then watch the videos for 13.2, okay? The reason being is if I go over 13.2 right now, it can be a little bit overwhelming. It can be like, man, that's a lot of material. And so I kind of want you guys to have an opportunity to do some work for 13.1 whenever y'all get a chance to. Remember, guys, this stuff here from chapter 13 is not due until the following Tuesday, right? A week from tomorrow. So I'll tell you what, I'm going to stop recording.